So let's run through some of the calculus you need to know before we jump into the differential equations part of this course. And so here is there are several formulas that we need to remember that we work with quite often. All right, so the first thing we're going to look at some derivatives. So the derivative, remember that notation, of the function e to the x, of the exponential function. You'll remember, of course, that is just itself. We use the exponential function a lot in differential equations. In fact, it is actually, differential equation is actually the place where the exponential function began. So, but the nice thing about it is it's the only function that is its own derivative. So very simple derivative, just something you need to remember. But if we change it a little bit, if we add a little bit more to that function, then now all of a sudden, in order to differentiate that, we have to use the chain rule. And so the chain rule says, take the derivative of the outside function, which is this e to the x function, and then we've got this inside function, which is just 3x. So 3x is inside of the exponential function. And so the chain rule applies when we've got a function inside of another function, a composite function. And so the derivative says, all right, you just take the derivative of the exponential function, which is just a copy of itself. And then you have to take the derivative of the inside function, 3x. And of course, the derivative there is just 3. So 3e to the 3x is the derivative. All right. And of course, we can get a little more, even more complicated. E raised to, say, the x squared minus 2x plus 6. Composite function, the x squared quadratic function there is the inside function, and so we're going to take the derivative of the exponential function, which is just a copy. You just copy everything down, leave the inside alone, just copy it as is, and then you take the derivative of the inside, which looks like that, and there's our derivative. So some derivatives of the exponential functions to get us started. Now let's go to the inverse of the exponential functions, and these are the natural log functions. And so the natural log of x, if we want to take the derivative of that, remember this is log base e, but the derivative of that is just 1 over x. Okay. Now if we complicate it a little bit more or compose the logarithmic function with something else, say x squared minus 4x. Now we have an inside and an outside function, and so we take the derivative using the chain rule. It's going to be 1 over x squared minus 4x. That's the derivative of the natural log part. And then times 2x minus 4. And of course we can clean that up just a little bit, but we'll leave it there for now. All right, so that is using the quotient rule. All right, now we need to remember our other rules of differentiation, one of which will apply right here. And so this, to take the derivative here, this is going to require the product rule, right? And so you'll remember that the product rule, if I want to take the derivative of uv, of the product of two functions, it's just the derivative of the first function times the second plus the derivative of the second function times the first. All right? And so our first function, in this case, is, of course, the e to the 3x, and our second function is this right here. And so we'll take the derivative of the first, and that's going to require chain rule, so it's going to be e to the 3x times 3 times the second function plus, now we take the derivative of the second function, which is just a nice polynomial, and so that's going to give us 20x cubed minus 6x squared times the first. All right, and now you'll see some simplification that you want to get used to here. The big trick here is to factor out an e to the 3x from everything. And so when I do that, I can then multiply the 3 through, distribute it through. So I get a 15x to the fourth minus 6x cubed plus 3 plus 20x cubed minus 6x squared. And then, of course, we can simplify this polynomial. We'll leave it to that. But that is the derivative of that. So that's an example of our product rule. Now, let's do one more to illustrate one more big rule. And it's going to look like this. The derivative of natural log of 4x cubed over x times x plus 3. So this is pretty complicated. This is going to require, at first, you see that it's got a fraction. And so it's going to require the quotient rule, right? So let's remind ourselves of the quotient rule. This up here was the product rule. I'm writing these down so that, if you want to see more examples or, look for YouTube videos on this, you can just search for quotient rule or product rule. Anyway, the quotient rule is how we take the derivative of a quotient, right, when we've got a fraction there. And so it's going to be v times u prime minus u times v prime over v squared. All right, and so that's one thing you want to remember. There's a little, a little chant that you can use there. Lodi high minus Heidi low. All right, and over low squared. That's a quick way to remember the quotient rule. But again, you might want to review that. So here we've got the quotient rule in play, and we've got our top function. This would be the u, and this would be the v. Now the tricky part here is when I go to take the derivative of either of those as part of the quotient rule, they're individually going to require, well, the natural log, u, I'm going to be using the chain rule when I take the derivative of it, and then the denominator, x times x plus 3, when I actually take the derivative of that in v prime, I'm going to have to use the product rule. So I've got product rules and chain rules inside of this quotient rule. And so this is what it's going to look like. So we take the derivative, we take the low function, I should say. So our derivative is x times x plus 3, that's v, times u prime. So the derivative of ln of 4x cubed is going to be 1 over 4x cubed times 12 x squared. That's the chain rule. So that's the vu prime term of the quotient rule minus u v prime. And so now I need to take the derivative of x plus 3. So it's going to be the derivative of x, which is 1, times x plus 3, plus the derivative of x plus 3, which is 1 times x, right? So you can see we've got a lot of algebra to work here. And we might actually not run through the entire simplification of this, because now it's algebra, right? Now it's working out and combining some terms. And so I think that's probably a good place to stop. We'll just put here that you can still simplify this, but that's going to be our derivative of that complicated function.